Here's example 5 with trig identities. So again, real quick, if you want a copy of this packet that we're using, check the video description. You can click that link, open it up, and print it out. Okay, so here's our general process from an earlier video. So again, always start on one side, try to make it look like the other side, and usually start with the side containing the more complicated expression. So here, sine of theta, and then this mess here. So the right hand side is a little more complicated, so let's start on there. Okay, so tangent of theta times cotangent of theta divided by cosecant of theta. Okay, so what's that going to equal? So there's a bunch of different ways to approach this. We can convert everything to sines and cosines, or we could use some of the other simpler identities without doing that. So let's try and keep it as simple as we can. So tangent and cotangent, are those related at all? Well, tangent and cotangent, it's actually not written on the sheet here, but remember tangent and cotangent, actually, yeah, here it is. Cotangent of theta is 1 divided by the tangent of theta, right? So let's use that. And let's also use the fact that cosecant of theta is 1 divided by sine of theta. Okay, so let's do that. So tangent of theta times cotangent of theta, that's tangent of theta times 1 divided by tangent of theta. And then on the bottom, what do we have? Cosecant of theta is 1 divided by sine of theta. Okay, so kind of a big old mess here, but we'll just keep simplifying. And again, this is not the only way to do this. Okay, we could have converted tangent and cotangent to sine and cosine also, and we'd still end up with the same result. Okay, but anyway, let's continue with this. So tangent of theta, cancel, cancel. So on the big top, we're just left with 1. So what we have is a 1 divided by 1 over sine of theta. Okay, so it's really, you know, this whole thing up here divided by this whole thing down here. So this whole thing up here just became 1 because tangents canceled. And down here we still have this. So now if you divide by 1 over sine of theta, that's like multiplying by the reciprocal, right? So what we have is the top, which is 1, times the reciprocal of the bottom. Well, the bottom is 1 over sine of theta, so the reciprocal is just sine of theta over 1. But these 1s are, you know, we just don't need those at all. So that's really just the same thing as sine of theta. And that's it, okay, because that's what we wanted. Okay, so in this case, we started on the right side, and we want to make it look like the left side, or we want to show that it equals the left side. So that's exactly what we did. And that's that, check mark, we're done. So again, what do? We used one of the reciprocal identities, or actually 2 of them. So cotangent is 1 over tangent. We use that fact, and we use the fact that cosecant is 1 over sine. So, you know, we didn't have to go about it that way. There's a few different ways we could have thought about it. Okay, so we actually could have left cosecant as cosecant, and we would end up with 1 over cosecant. And that's automatically right away, that's sine of theta. That's one way to think about it. Okay, just a bunch of different ways to think about it. We also could have converted tangent and cotangent to sines and cosines completely. We still end up with a 1 on top. Okay, so lots of different ways to think about it. That's sort of what's nice about trig identities is, you know, it might be kind of hard to see how to do it at first, but usually there may be a few different ways to do it. So there's generally not going to be, you know, just one right way. There might be multiple ways to approach it, which is helpful in a sense. So anyway, that's example 5 with trig identities. Example 6 coming up next.